For section 1.3, the learning target, I will be able to use distance and midpoint formulas. You will hopefully recognize these from Algebra 1. We're also going to be looking at Pythagorean Theorem, since Pythagorean Theorem is directly related to the distance formula. Feel free to pause the video, get this written down, then come back in and add in what I talk about. So for bisect, so our vocab term bisect, you will see this often. Bi means two. So we're going to bisect something is going to be to divide it or split it up into two equal pieces. A lot of times kids like to say split it in half, which is true because you're going to go halfway, so each half is going to be equal. However, in geometry, what we do a lot is write equations. And so thinking about it as splitting it into two equal pieces is going to be much better for you to be able to write an equation, because you're going to have to be setting one piece equal to the other piece instead of thinking of half of something. So try to really train your brain when it says bisect to mean splits into two equal pieces. Now we can bisect all sorts of things. So this is bisecting a segment, splitting it into two equal pieces. These little things right here, these little red marks, they're called tick marks. Okay, and tick marks are ways that we show in geometry how two lengths are equal, how two segments' lengths are equal. One of the big things you cannot do in geometry is assume anything. So if it doesn't tell you that things are equal, you can't just think that they are. You have to have a reason for it. So on a diagram, to know that this is actually the midway through the segment, you have to see these marks to know that those sides are equal. Or in angles, which we'll talk more about in section 1.4, this blue ray right here is bisecting this angle. These little things right here are called arc marks. So these arc marks are the same thing that tick marks do. It just says these two angles are equal. We just do a curve inside the angle and these little straight tick mark lines on segments. So like I said, algebraically, so when we set up an equation, you're going to be thinking about one piece equals the other piece. And these are just blanks that you're going to fill stuff in. So maybe there's going to be algebra on it. So maybe I'll not use a box right now. I'll do a blank. So you're going to have something equals something else. So maybe these are each 5 or they're both 10x, but they're going to be equal to one another, those lengths. Midpoint is what this point right in the middle is called. So the point that bisects a segment, this needs to not have an arrow on the end of it. Okay, so this is called the midpoint. It's the point that bisects a segment into equal pieces. So this blue thing right here is called the midpoint. Again, it'll split it into two equal pieces, just like the word bisect means. They do the same thing. Okay, except for a bisector could be a ray or a point or other things. A segment bisector is just the thing that is bisecting the segment. So whatever is doing the act of splitting it into two equal pieces. So if you see in a sentence, it says that the segment is being bisected by a line, by a plane, by a point. Okay, it's still bisecting or splitting up the segment. So this blue thing right here is the segment bisector. And it is splitting the segment again into two equal pieces. So the algebra behind it is still the same, or the formula is to say that this piece is equal to this piece, whatever they're labeled. Okay, so algebraically, this is what it means, that the two pieces are equal to one another. Then let's take a look at a couple of formulas here. So Pythagorean Theorem is huge. You learned it in Algebra 1. It's going to keep coming back throughout geometry and the rest of your math career. So c squared equals a squared plus b squared. It's important that this is a right triangle. It has to be a right triangle. And again, you need to see the right angle. You need to see this box right here that tells you that that's a 90-degree angle. Can't just look like a 90-degree angle, has to actually be one. Then the c is the hypotenuse, which is across from the 90-degree angle. Sometimes kids struggle with plugging the correct value in for C. They plug the wrong one in. One thing I tell people to do if they struggle with that and don't know which one goes in for C is to draw an arrow across from the 90-degree angle and circle it. That one goes in for C. The other two, it doesn't matter, okay? A and B can be either one of the legs. These ones are interchangeable, can go in wherever, okay? Can go in for either A or B. It's that C value that has to be the one across from the 90-degree angle. So C squared equals A squared plus B squared. Midpoint formula, so if you are given just 2 points, okay, so two ordered pairs like you see down here, this -2, -2, and 8, 4. If you're looking for the midpoint, this is the midpoint formula, okay? So you're going to have 2 points labeled, okay, and you're going to have an x, your first x coordinate, your first y coordinate, and you're going to have your second x coordinate and your second y coordinate, whatever they are. You're going to add the 2 x coordinates together here and divide by 2. Then you're going to add the 2 y coordinates together and divide by 2. So you're just coming up with the average of the x's, or the middle, the average of the y's. If you've done it in table form before, which I think you did in Algebra 1, you can put these endpoints on the edges of a table. So make a three unit table, okay, with 3 places, and the endpoints go on the top and bottom. And then the middle is for the midpoint, right? Because the midpoint is the middle, so that goes in the middle of your table. So put the 2 endpoints, okay, and remember that this is the x and this is the y, so the points go in across the table. So -2, 2, and then 8, 4. And then I'll show you how to get to this middle. You actually just find the middle of these 2 numbers, and I'll show you that in an example. The final formula for today is distance formula. So the distance formula is D equals the square root of x2 minus x1. So you subtract these x coordinates. You take one x coordinate minus the other one, and then you square it, plus you subtract the y coordinates and square them. Just don't forget this square root at the end. That's what a lot of people do. Otherwise, on a table, you can actually connect it back, or sorry, on a graph, you can actually connect it back to the Pythagorean Theorem. And you can do that by drawing a right triangle on there and just doing the Pythagorean Theorem. So you can draw a horizontal line from one endpoint and a vertical line from the other until they cross. And then you can actually do Pythagorean Theorem here, with these 2 red lines being your A and B, and the blue one being your C value. And I'll go through examples both ways. So for this example, it says graph a right triangle with 2 points forming the hypotenuse. So we've got these 2 points already plotted. So we need to make a right triangle with that as the hypotenuse, just like what I just showed on the last screen. So draw a vertical line from one endpoint, a horizontal line from the other until they connect. And then that will give you a right triangle, because a vertical line and a horizontal line are always perpendicular to one another, or always form a 90-degree angle. Then just count, okay? So count how long this segment is. So it's 1, 2, 3 units long. And then you can count this one, 1, 2, 3, 4 units long. And then remember, we're finding this, the length of this dotted segment. So I'm just going to call it x. So we're going to go ahead and use the Pythagorean Theorem here. So c squared equals a squared plus b squared. Remember, we are plugging in the hypotenuse for the c value. So we're going to put an x in for c. So we have x squared equals, I'm just going to go a squared plus b squared so we can fill them in. So your a and b value are this 4 and 3. They can go in whatever order over here. And then we're just going to simplify. So x squared is just x squared. 4 squared is 16. 3 squared is 9. Add those together and you get 25. And then to undo a squared, we will square root both sides. And algebraically, you would actually get a plus or a minus 5 here because negative 5 squared is 25 and so is positive 5 squared. However, in geometry, when we're talking lengths of segments, we can never have negative lengths. So the only answer to this problem is positive 5. And then it says to the nearest tenth, if necessary means if we have decimals and we don't. So we would say that the length of this is just 5. Find the distance between 2 points given just 2 ordered pairs. So here I'm going to do the distance formula. You could graph this and do what we just did if you had graph paper. But let's go ahead and do the distance formula. So remember that that's x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared, and then the square root of that whole thing. Remember, you have an x coordinate and a y coordinate of your first point, an x coordinate and a y coordinate of your second point, and then you're just going to plug these in. So I'm just going to rewrite down the spots that we are going to plug stuff in. So we're going to plug in for x2, x1, y2, y1. So in this first one, we're going to pick the x coordinate of the second point minus the x coordinate of the first point. Then we're going to do the y coordinate of the second point minus the y coordinate of the first point. Then we're going to simplify inside each of those parentheses. So for this one, we have -6 minus a -8. So remember, when you subtract a negative, becomes a positive. Those two negatives together make a plus. So this is really -6 plus 8, which is 2. And then we have 0 minus 6, which is -6. Okay, then square those out. So you have +2 squared, so 2 times 2 is 4. And then here you have -6 squared. So this is -6 times -6, which is +36. Be careful typing that into your calculator, because a lot of you make the mistake of typing -6 squared like this. And then you get -36, which is wrong, because you're squaring -6. So you need parentheses around that with a squared, so that it will do so your calculator will do -6 times -6 to get +36. So be very careful there. Add those together and you get 40. So then square root of 40 and whatever the decimal version of that is. So let's see. So 6.32. And then I think the original problem here told us to round to the nearest tenth. So we got 6.32. So to the nearest tenth, that would be 6.3. Find the midpoint graphically. So on a graph, to find the midpoint, you can actually draw a rectangle around here if you wanted. And so starting at each point, going to the next one, drawing a rectangle using the endpoints. I'm just going to make this a different color. And then you can split the sides of the rectangle in half to find out where the midpoint is. So you can actually just count here. So this is 1, 2, 3, 4, 5, 6, 7, 8 boxes wide. So the middle of 8 is 4. And you can draw a line there. I'm just going to make it a little bit skinnier. And then you can do that again on the other side. Okay, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9 boxes. So this one, half of 9 is 4.5. So 1, 2, 3, 4.5 is going to be where the middle of that side is. And then that will locate your midpoint. So then you just count from the origin, plot that point. So 1, 2, 3, 4 is your x, and then 1.5 is your y. So that's the midpoint. So that's how you could do it graphically. You can also do it in a table. So like I showed in the example, and you would put, or in the formulas, and you would put the ordered pairs. So this ordered pair is 0, -3. That's an endpoint. And then this endpoint is 1, 2, 3, 4, 5, 6, 7, 8 is the x. 1, 2, 3, 4, 5, 6 is the y. And then you just need to find the middle of these two numbers. Okay, so the way that you find the middle is 0 plus 8 divided by 2. It's just average. You have two numbers, add them together, divide by 2. So we get 8 divided by 2, which is 4. And then same with the y's. So we have 2 points. So you would add them together, the y's, and then divide by 2. So -3 plus 6 is 3. Divided by 2 is 1.5. And that gets you that midpoint as well. You may also just even know that the middle of 0 and 8 is 4. That's fine. Midpoint is just the middle. Okay, so however you end up getting to the middle is totally fine. Final example here, I'm going to do midpoint. Given the midpoint, find the end point. So versus the last one, I gave you the starting and stopping point on the segment and told you to find the middle. This one, I'm going to tell you what the middle is. Okay, so this one, I'm going to plot 7, -2. That's the middle. Okay, then one of the endpoints is 8, 3. Okay, so if I were to draw just over here, this is what this segment looks like. We've got an endpoint, we have some other endpoint, and we have the midpoint, right? So here's what I've plotted. I've plotted this red point, and I've plotted this middle point. This is what we're looking for right here. Okay, so you have that 1/2 of the segment, and you're looking for the other half. So it should be the same exact distance from red to blue as blue to the next point. So just draw in those little slope triangles, like go from here and just walk this path straight down and straight over. And I would just count it. So count what you did there. So you went 1, 2, 3, 4, 5 over 1, and then repeat that. So go 5, 1, 2, 3, 4, 5 over 1, and that's your other endpoint. So 5, 1, here's your other endpoint. Then you just have to figure out what the ordered pair is for that. So count over to here is 6, down to -7. So 6 down to -7. That's how you can find that answer from the graph. So then let's take a look at how we could maybe do this in a table, because if you don't have graph paper, maybe you want to know how to do it in a table. So in a table, what we would do is still put the endpoints on the end and the midpoint in the middle. So now this 7, -2 goes in the middle because it's the midpoint. And then you can put this endpoint on the outer part. So now this needs to be in the middle. So I would just look at this table. How far is it to go from 8 to 7? Well, 8 down 1. So I went down 1. I just need to repeat. So I need to go down 1 more. So 7 down 1 is 6. Here, for the y's, you went 3 to -2. Well, how far is it from 3 to -2? That's down 5. So now I need to go down 5 more. I need to repeat that to make it the same distance away and be in the middle. So -2 down 5 more is -7. And whoops, moving myself. And then again, this is the same as that ordered pair.